Okay, so let us solve a new problem. So this problem is called unique paths. The problem says there is a robot on an m into n grid. The robot is initially located at the top left corner, grid 0, 0. The robot tries to move to the bottom right corner, that is grid m-1, n-1. The robot can only move either down or right at any point in time. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. So we need to find out the total number of ways that the robot can move. So as you can see, there is a robot here in this position in the grid. So he can either move right or he can move down, right? He can move right or he can move down. So what we need to figure out is in how many ways can the robot reach this position in the grid. So since we need to try all possible ways, again we have to try recursion. So what we can do is let us start in reverse, right? That's how I solved my dynamic programming questions or recursion questions. So let's start from here, m-1, n-1, right? We'll start from here and we'll try to make our way up to the top. So since in the initial condition he can either move right or down, so if we come from the reverse position, that is from the finish line, then he can either go up or left, right? So let us try that. What we can do is we can just return a function. Let me maximize this thing so it becomes easier to see. So we can start from the m-1, n-1, and yeah. So we are treating this as an index in an array, obviously. So we start from the m-1 and n-1th position. And what is the base case? The base case would be if we reach the 0, 0 position in the grid, right? And whenever we think of counting ways in recursion, right, this is how we do it. So we mention base case first. Base case, and if our I forgot the function, public and f, right? Let's take this stupid base case inside. Take the base case inside, and then we are working on an index, but since this is a grid, one index will not suffice, so let us use two indexes. Now if our I equals to 0 and our j equals to 0, this means we have reached the initial position in the grid, then we can count this as one way, right? So we return 1. Okay. See you in the morning. a little bit of this, and then so also if we are in what can be an edge case, right? Like suppose we are here in the finish line, and then we move here, and then we move here again, and then we move up again, so we are crossing the grid, right? Or we can move here towards the left, and we can go beyond the boundary of the grid. So we can put an edge case for that. What we can do is if our I, right, if our I is lesser than 0, right, or our j, that is the column length, is lesser than 0, right, where is it, is lesser than 0, then we do not count that path, right? We can just return a 0. Otherwise we can either go left or we can go up. So let us write the recursion for that. We can go left, that is f of left would be, we're in the same row but different column if you go left. And as for the right, no, not right, we need to go up. If we go up, then our row changes, that is I minus 1, but our column remains the same, right? And in the end what we need to return is like either I go left or I go up, right? Those will be two ways. So I need to count the sum of those two ways, right? Like if I go up there is one path, and if I go left there is another path, right? So in either of these paths, if I manage to reach the destination, then I need to count it. So what I can do is return left plus right. Yeah. I think this should work. Let's try. Cannot find symbol. What cannot find symbol? Variable, right? Oh, sorry. Left plus up. We tend to make these mistakes, but that's okay. Yeah. So the recursive solution is working. Maybe we can move to the memoized solution, which is going to be really simple, right? Because there will be I and j states. So we can just declare a dp array, right? That will store all these values. So new int m into n, right? Because that's the grid. And then all we need to do is we need to initialize it to -1. Why -1, you say? If you are someone who has never done dynamic programming before, -1 is used to specify that for this particular location we have not calculated a value yet, so we need to use some kind of a marker to specify that this value has not been calculated yet. So yeah, I less than m, I plus plus for int j equals 0, j less than n, j plus plus, and dp of I j equals to -1. Done. Once we're done with that, we can pass the dp array. We can accept the DP array here, right? And then once the base cases are taken care of, if our DP of I j is not equals to -1, then we return our DP of I j, right? And here, instead of returning this value, we can also store it, right? DP of I j left. I think we are okay. Just run this. What's my mistake? I did not pass DP here. DP. We love DP, don't we? DP is beautiful. Yeah. Let's try to submit this and see if this runs. Yep, 100%. So as for the time complexity of this problem, how many states are possible? IJ, right? IJ or not IJ, size of the grid. So m into n. That's the time complexity. As for the space complexity, we have those many states, right? And the recursion stack. So we also need to store, I think. Wait, we are storing the DP array, right? Into n, right? Plus the recursion stack, right? So what's the maximum recursion stack that can be stored? That is, if you think about it, if some person moves down, and then left, right? You know what? I'm going to pause for a moment. I'll be back. The solution is done, really. There's nothing left to do here. But I will be back. Be right back. Okay, I'm back. Thank you for waiting for me. Where was I? Here. So we have finished the memoized solution, right? So the time complexity would obviously be m into n, that is the number of states, and the space complexity would be m into n, obviously, for the DP array, and recursion stack would be let's just go back. Wait, how do I go back to this? Yeah. This is stupid, man. This is just stupid. Let me open this page again. Hopefully it's still saved. How do I fix this layout? Okay, I got it. Unfold. Yeah, so the space complexity, right? We are using a DP array, so it would be m into n. And what about the recursion stack space? So suppose we're standing here, right, and we would go right, down and down, right? So at max it would be m, if this is m, right? This distance would be at max n, right? And this distance would be m. So the total space complexity would be m plus n. That would be in the worst case. So what we want to do is we want to improve this, right? We want to remove this recursion stack space if we can. So that's where tabulation comes into place. But then I'll not be doing the tabulation solution today, because I need to do something else, and for that reason I'll be ending my stream here. Hopefully someone here got to learn something new, and yeah, I'll be seeing you on my next stream, and we'll be solving the tabulation method, right? I mean, we'll be using the tabulation method to solve this problem so that we can avoid the recursion stack space, and we'll see if we can use space optimization as well. So yeah, hope you have a wonderful rest of your day. Good night.